Let's go ahead and take a look at the design of the periodic table. Although the periodic table is organized in many ways, it's primarily organized by increasing atomic number. As you make your way from left to right across the periodic table, the atomic number always increases by the number of 1. The periodic table was first organized by a Russian chemist in the mid-1800s named Dmitry Mendeleev. As you can see, Mendeleev's periodic table looks similar to ours today, except it has about half the number of elements that we had. Now, Mendeleev organized these based on their properties. As you can see, there are several holes as well because some of those elements were undiscovered at that time. Let's look at the columns on the periodic table. There's a total of 18 columns. Those numbers are usually written up at the top from left to right as you move across the periodic table. Columns are also called groups or families. These are synonyms. So depending on the resource that you're reading, sometimes it will say the word column, group, or family. Just know that they're exactly the same thing. Elements are put in the same family because they have similar properties. The element family shown here to the right, these are the alkali metals. Of course, they're all metals based on their name, but they have other similar properties, such as their reactivity, their valence number, and then they're all very soft. Let's look at our rows on the periodic table. As you can see, according to the color-coded key here, there are a total of 7. The 2 at the bottom are part of rows 6 and 7. They're just dropped down, so the periodic table is not so wide or extended and easier to read. Each horizontal row is also called a period. So just like families, groups, and columns are synonyms to one another, each horizontal row could also be called a period, meaning the same thing, an area from left to right on the periodic table. Looking at each row, the first element, so each element in column 1, is a reactive solid. And as you move your way across the table, the last row in column 18 is an inactive gas. Let's classify these elements now. Elements have 3 different classifications that they'll be placed into: a metal, a nonmetal, or a metalloid. Metals are to the left of the bold line on the periodic table. I'll show you that in just a moment. Nonmetals are to the right. And our metalloids, those are the elements that are actually bordering the line on either side. Here you can see our periodic table, and hopefully you can see our bold line just under the element boron and in between aluminum. That is a zigzag kind of staircase line. Again, let's review. Elements bordering that line, those are your metalloids. Now, aluminum is an exception. Even though it's touching that bold line, it is actually a metal. Elements to the left, again, those are your metals. Now, we know that hydrogen, the element up at the top left, that's to the left of the bold line, but we know that as a gas, so that's a nonmetal. Elements to the right, those are your nonmetals. Things like carbon, nitrogen, phosphorus, chlorine, all those to the right are considered your nonmetals or your gases. Let's look at our element key. Our element key tells us exactly what's in each box. Some periodic tables have a little bit more, some have a little bit less, but let's go over the 4 main ones that we should know. The atomic number, the top number, that's the number of protons in the nucleus. That's its definition. But as we know, if an element is stable or neutral, we know that the number of protons must equal the number of electrons. So for element sodium, if it's neutral, also has 11 electrons. Our chemical symbol and the chemical name, the next 2. The chemical symbol is simply an abbreviation. Sometimes it's 1 letter and sometimes it's 2. If it's 2 letters, one of those letters will be lowercase, the second letter. In this case, sodium, Na. Now, why is sodium Na and not something like S or SO? Well, because not all chemists were English speakers, and there's a lot of Latin chemists at the time that were discovering elements. And our bottom number, the last one. This is the atomic mass. This is the number of protons plus neutrons combined in the nucleus. So if we wanted to find the total number of neutrons, we would take the number 23, because we would round that average atomic mass to the nearest whole number, and subtract the number of protons, leaving us just with neutrons. So sodium has a total number of 12 neutrons inside of the nucleus. Lastly, let's take a look at properties of each of these three categories. Of all the elements, approximately 3/4 or 75% are metallic, shown in red on this color-coded periodic table. Again, look at hydrogen in the top left. That's darker blue. That's a non-metal. Thinking of properties of metals, metals have luster, so they reflect light. They're shiny. They're good conductors of heat and electricity. They have a high density and high melting point. They're ductile, which is known to be drawn into thin wire, such as an extension cord. And they're malleable, which means they can be hammered into thin sheets. Think of a car door or a piece of aluminum foil. Our properties of nonmetals. Well, they're the opposite of metals. They don't have luster and they're dull in appearance. They don't conduct heat or electricity. They're brittle. They're not ductile or malleable. They have a low density and a low melting point. And lastly, our properties of metalloids. Properties of metalloids kind of can have properties of both metals and nonmetals. They can be shiny, some can be dull, some can conduct heat, some don't, some are malleable, some are ductile. So here ends our design of the periodic table.